G'day, welcome back. This is the next video in my series on chess software. Didn't quite know to put this video actually. And we're going to have a closer look at the WDL metric, which you get out of Leela, LC0, and engines of that sort of fully neural network type, where you don't get a centipawn evaluation of the position, i.e. plus one pawn, plus 4 pawns, whatever. You actually get an evaluation of the percentage chances of a win, a draw, and a loss. I mean, obviously there's some equivalence there. I mean, people talk about, maybe 150, 200 centipawns is a draw to a win. So you can imagine that would change it from a 50% win, draw, loss to 90% win type scenario. So there is this equivalence, but obviously what we're thinking here is equating a win, a draw, a loss actually gives you much more information about the type of the position, because if it's 33% win, 33% loss, 33% draw, that's a different position than 1% win, 98% draw, and 1% loss. So you get a bit more perspective on how sharp or uncertain the position is, which is extremely useful. And I'm just going to briefly do sort of introduction of that concept in this video and look at a few of the charts I've done before, so that we can sort of get some more insight into some of the games we looked at before and the World Chess Champions and so on. So that's the intro. So let's go and have a quick look at what we're talking about. The first thing I'm just sort of trying to outline that sort of what we're going to go through today. And out of the way, there's this sort of what we're going through. We're going to talk about WDL. Take on the calculator, some of the differences, and show you some examples of it. And then basically what I'm going to then do is go straight through, if you have a look at the previous analysis I did of the accuracy of chess players versus how, but now we're going to be able to assess it versus how complicated the positions were, or how sharp the positions were, and get a better insight into it. So to what we're doing. First thing I'll do is how do we extract the WDL? Now I've just got a very simple bit of code here, which just like a snippet. Have a look at that. Unfortunately, I'm doing this on a VirtualBox, doesn't have pass-through of the GPU, so you actually need to use Leela for this, but Stockfish does give you a WDL. Not too sure how it does it. I mean, it does have the node uses a neural network. I don't know if they try and backpropagate some of that position through the engine or not, or they just come up with a simple conversion of centipawns into what they think WDL would be. So I wouldn't do this in general. You'd actually point your engine to LC0, you'd run it, and then you run this command, which shows the WDL in what you get returned from the engine, and then you can print it out, right? So that's fairly simple. You just put a position in, you can take a fan, or it can just be the starting position. So let's run one of those. Right, so there's the starting position, right? So I've thrown it, show WDL, and it's here. This tuple, I guess, is a tuple class, gets returned. And from the starting position, it's telling us 9% chance of white to win, 9% chance of a draw, and 2% chance of a loss. Now, there are some factors here that sort of parameters we can play around with, the WDL contempt factor and so on. So you can play around with a bit. You might get different numbers. And if you use Leela, it might give you different scores there. So I stitched this bit back in because I wanted to show one more thing. You'll notice in this underlying WDL code, using argv, it actually takes a parameter. You can pass a fen in, and it'll give you the win, draw, and loss calculation, which is done by the engine. In this case, it's Stockfish, so it's not correct in inverted commas. Anyway, it gives you a sense. And I'm just let me just run a couple of them. So you can see it shows you the board position there, which is Fischer, Spassky, or Spassky Fischer, after Fischer's just taken the pawn on H2. And you can see that position would still be considered a draw. It's proof of concept, by the way, because obviously this is a Stockfish WDL, not a Leela one. I've got the Leela one in my other database. Just want to sort of show you sort of a sense of it. Whereas the other position I've fired up, we're going to look at this later on as well. Let's see if this works. Okay, this is the position of short Kasparov just after Short's made the blunder. Rook takes f7 check, and this game peters out to a draw. And you can see in this case that actually it's thinking it's this is a position which is not certain. Draws 700, losses, i.e. wins 300. Once again, you can see that that's from the black's perspective. Just so you understand, WDL for whatever reason is scaled up to adding up to 1,000 as sort of the sum of the results. Anyway, I just wanted to show that, just to give you a sense of the sorts of numbers which come back out. And then what we're talking about is you then take these three numbers and you put them through some function which measures or gives you a measure of sharpness or how wild the position is. that's just how easy it is. If you've got an engine which provides WDL, that's the sort of framework you'd use, and then you'd go through the positions in the game, throw in WDL, and you'd be able to get sort of the leader's assessment. Now this gets on to this second point I was talking about for blunder checking. Now, in the past, I've been using centipawns for my blunder series, and I've been looking for 250, 300 type of blunder, depending upon the position, and which is fine. But obviously you can do the same thing here, but now looking at the change in WDL. Now the change in WDL is actually, it's self-correcting, which actually makes it quite a bit more useful in some ways. So I want to do a bit more analysis. Bit of it today, bit of it in future videos, is if the position's already lost, then another blunder and centipawns just won't show up, right? Whereas won't show up in the game result, but it'll certainly be another blunder you have to look at. Oh, you're 500 down, now you're 1,000 down, or whatever, right? But WDL kind of self-corrects because it would have been 95% chance of win. Now it's 96% chance of win, so you don't have to filter for that. And also, if it's a complicated position, a one-pawn loss actually may not show up as a blunder in terms of the change in the WDL, but it's a very simple position, endgame pawn loss. It goes from a draw to a loss. So you can see this WDL parameter can actually be pretty useful for filtering out blunders and really focus a bit more on blunders. And we'll see a bit more of that. And then I quickly thought we can have a quick look at Nibbler again here. You see how Nibbler works with the analysis game. Once again, this is using Stockfish, so the WDL is not really true, but have a look at that and you can see that it's giving you the depth analysis and the win, draw, loss. Now, when using Leela, once again, how far do you go forward? If you go forward to infinity, obviously Leela will know the answer. And if you just do a very brief analysis, win, draw, loss, it'll be a bit more uncertain. So that's another parameter people play with in terms of when they're looking at win, draw, loss ratio. So Nibbler is designed to actually showing you the win percentages or the average white's perspective, 54% E4. There you go, best. So that is Nibbler, which has been designed more with Leela in mind, right? And then now, see, it's 90% black should play at D5 attacking the G pawn. Just gives you a sense, and you can see that it's moved from win, draw, loss. Okay, this is from the player's perspective. Now it's 75% chance of black winning and a 25% chance of draw. Okay, so that gives you a sense of that. So, so what you can do is get the WDL, store the information somewhere, and then you can start charting games. So let's have a look at a couple of games. Okay, here's first game on my database. So the data I'm using, by the way, is just going back to my World Chess Championship data, and I have saved WDL in a separate file. WDL, you could save it in the PGN as a comment, but then obviously the comment file gets more and more onerous and heavier. So just for this purpose, it's just saved it across in the CSV file. I've got to work out something better. So here's first game, Zukertort Steinitz. And you can see that I'm plotting the WDL. Win is green, loss is red, and from white's perspective, and the draw is the dotted line. And you can see this game, basically the loss by white, should be lost by white. And you can see how the game progressed, some uncertainty around the middle of the game, and then went more and more to the loss, and the draw got out of the equation. But you can imagine a slight blunder here where the chance of a draw increased and then disappeared pretty quickly. So that gives you the profile. And the way I've done sharpness, I've just done the standard deviation of the outcome. You know, you've got three outcomes, 0, half, and 1, standard deviation. There is a really fancy formula. Let's have a quick look while we're here at there's a few interesting things you can go and look at. Here's a good blog by JK182, and he's the same sort of chart as mine. And he's using WDL to analyze games, and then he's thinking more about the actual sharpness of the position. I'm not going to go through this. You can go and have a look at this blog later if you like. If you got the fancy formula I'm looking for. It doesn't have it anyway. So there's a formula for converting chance of a win, chance of draw, chance of loss into sharpness. I've used a slightly different formula. I think they're similar, but I might move on to using their formula. Another couple of things here. If you look at this sort of stuff, you should definitely look at Ken Regan's material on chess ratings, which uses a different sort of decision-making under uncertainty process for trying to work out how accurate moves are, which is kind of where I'm heading to. And this was the original paper, which actually a lot of people refer back to, Guid and Bradko, which took engine, took centipawns, worked out how accurate World Chess Champions were, which is where we're headed now. So I just thought that's sort of some material you can have a look at. Let's close that. And this is the position where it was in the game we just looked at. This is the minimum sharpness. Yeah, that doesn't look so sharp. I think it's just lost. And this is the maximum sharpness of 55. So I've got these numbers between like 0 and 50 or 60 as terms of symmetric. Right? It doesn't matter what the actual values are, just symmetric looking at things. Right, so as I said, the data set, World Chess Championship. So what I do now is I run with a different set of data. That original analysis I did where I took center pawn loss, worked out who was most accurate, and then now I'm throwing in WDL and changing WDL as another metric of how accurate the plays are, and then using the WDL itself and the sharpness derived from that as a measure of how sharp the people's games are, and if, you know, were they blundering in sharp positions or were they blundering in easy positions, to get sort of another way of seeing how accurate these players plays. Now what I've got to do is I need to switch across to my other Ubuntu window. Let me see if I can find that. Okay, worked, perfect. Okay, let me switch across. I will point out I just upgraded Ubuntu on the other virtual box, and it was annoying because my automatic window positioner doesn't run anymore. WM control, see how that goes. Okay, so here we have, I've just run, this is from something you will have seen in one of my earlier videos, the accuracy of chess players bundled by the percentage frequency of errors at different definitions of a blunder. So you can see center pawn, 2 center pawns, 3 center pawns, 4 center pawns, and that's the frequency. So the lower down you are, the better. And, you know, there's we'll look at a bar chart in a sec, but you can see Gukesh is very accurate in his match against Ding. Ding's up there. I think Ding was very accurate against Gukesh, not so accurate against Nepo. Karyakin, obviously famous. So he had the old drawn match with Carlsen. There's Carlsen, there's Caruana, Liko, Anand. I think we're going to have maybe Kramnik hiding in there. Capablanca, Kappa very accurate for his time. But we're going to sort of have a look at the extra aspect of that, and all the way up to Günzburg and Tigorin and Steinitz, who weren't so accurate. Okay, that was one form of the information. And here is kind of the, let's call it the average of that. Gukesh very accurate, Ding Nepo not so much. And I think this chart we've seen before, and it really just reflects the systematic decline in error rates. But there's a few sort of aspects I think I colorized that Kappa and Schlechter very accurate at the time. This whole Bronstein to Fischer era, an era of better accuracy, but obviously Tal, but he played wild positions, Short's positions were quite wild, and effectively Topalov as well. So I think let's close that. And then I had to switch back to my other virtual box. Now this is where I've used the WDL analysis I was talking about earlier, and there is the sharpness of all games based on WDL. There is the sharpness per game based on the player. So Gukesh, average sharp, Karyakin, Carlsen, kind of the least sharp, or Capablanca the least sharp, and other players, Chigorin very sharp positions, Reshevsky, he was in the 48 match, and then Morrow, short, very sharp, and I think Tal's sharp as well. So it actually reflects what people expect. So basically, this is just the standard deviation of the possible result in the game. So that's one chart. The second chart. So this is the error measured in WDL change. I mean, I've scaled it differently, but obviously Gukesh and Ding very accurate. Karyak and Carlsen very accurate. Capablanca also very accurate. I mean, these are the sorts of numbers you talk about. I think Kramnik was supposed to be accurate. So short, not so accurate. Tal, not so accurate. So it's reinforcing everything we think is their styles. And here's the center point error. I just redid that. That was that the previous set of charts would match these numbers. And then here is error in the game result, which is WDL versus sharpness. And you can see that reassesses it. Like we're saying, short, very error prone, but actually given the sharpness of his position, it's quite okay. So basically you want to be over this side of the chart, not over this side of the chart. So funnily enough, I mean, Marshall was before Capablanca. Actually, I mean, it's not a linear relationship, but obviously Capablanca, lower error rate, but positions were very boring. Schlechter, same sort of analysis. Karyakin, he's sort of on the line, low error rate, but also not sharp positions. Carlsen the same, and few of these players, short I mentioned already. Where's Tal end up? Tal ends up kind of middling. He has a higher error game result than other guys, but he plays in much sharper positions. Here's the same chart with center pawns. Doesn't look that different, but I think actually using the change in the game result, i.e. the change in the standard deviation of changing the expected score, is probably a better way of looking at it. Not averaging out well, but this shows games sharpness average is about 17, goes down to 10. Yeah, so it's sort of what you expect in the game flow. Okay, so that's that set of charts. And I think it's pretty interesting. This is this thing about redoing the sharpness versus error per game. Makes Kappa look much less impressive. Carriac can look much less impressive. Makes tail and short look a lot better. Okay, so what I then did, let me see if I can find it. Actually, it's on this page. I went through everybody's games and came up with a list with their most exciting and their most boring game. A lot of parameters you can throw in here. Do you want sharpness over the core of the game, like moves 10 to 40? Do you want the whole game? Do you want like a rolling window, sharpness for 10? Anyway, I just took an average. I think moves 10 to 40, I think I took. What's the sharpness? According to my definition, you find the sharpest game and the least sharp game. So just to give you a sense, what I concluded is that let's have a look at game. There's 3 games to look at. Game 1, 2, 4. Let's look at game 1, 2, 4. Okay, so this is Marshall Lasker, and you see the full chart there? You can. That looks like a pretty boring game, doesn't it? Draw percentage, 80, 90, not much chance of wins or losses. And you can see the type of positions we're looking at there. It is basically, maximum sharpness was 34.6. This bobble here implies 76, so that's move 38. Actually, so I think I went further out, and this is there. Right, you can see this looks like a very boring game, and actually we can load that up. Say game 1, 2, 4. Have a look at how this game goes. Here's Gambit. Greens are off very early. These are all chopped. That's a very boring game. Okay, so let's now look at another game, the sharpest game from the Tal Botvinnik game. Now, I thought that might be game number 6. Actually, is game number 1. Have a look at what we get. You can see sharpest position, about 40s. You can see it's here. And you can see why. White has lost the right to castle. A lot of major pieces still on the board. I think only one pair of pieces has been swapped off at this stage. And you can see that on this evaluate, it stays sharp for quite a persistent period of time. I think Tal won this, game 1. I'm sure game 6 is similar, but we can go and have a look at this. So this is game 475. Let's have a look at that. So I just thought this is a very interesting way of looking at World Chess Championship matches. Now we've got this filter where you can say, what's the most interesting game? What's the most boring game? And then let's go and have a look at them, right? Chess Space might have something similar in terms of games with brilliancies or whatever, right? So here we go. Let's have a look at what this game looks like. Oh, it's a French winner. No wonder. Okay, so obviously the opening you play makes a big difference. This obviously is a sharp game. If you made a blunder in this game, no problems whatsoever. And what we do is, before I close out, we might have a look at one other game, which is 808, Kasparov short, or short Kasparov in this case. This is a very tense game all the way down, and then you can see at this point here, which is where short blundered and lost his chance. But you can see that game was an intense game, right? So let's have a look. You can see the maximum sharpness. You've got kings and queens in close proximity, and then later on, sharpness of 0 it is as that final position looks similar, but actually Leela looks at it, says, that's a draw by repetition. So let's go and have a look at this game. Go through it quickly. Remember, this was a sort of short was overwhelmed, but we were playing marshals, and here's a Sozin in this game. Open F file, charge in. Short castles on the queen side. Rook penetrates. And this was a mistake. I mean, rook takes f7, it's totally winning, but it's not, right? And the move to play was queen f6. Get back to my other video on blunders in World Chess Championship. So what can we say about that? Let me get back to my summary of what we're going to be talking about. Basically, we could use sharpness to assess the style of players' games, but like for players, for openings, for matches, and for eras. And obviously, I'm going to do a bit more work on that. And just a good way of filtering games and working out if they're interesting games, how tense the game is, and how that progresses through the game itself. And I mean, it's not really, you can see it's basically filtering mainly for the middle game phase of the game. And it's this whole point about if Leela can't work it out, looking at, I guess, a limited number of nodes, then you know that it's going to be difficult for humans. Okay, cool. So look, I'll stop there. I just thought this is going to be introductory look at the WDL. Earlier on, I listed all those sort of articles you might want to look at. There are some blogs on WDL. Anyway, so that's the intro to WDL. Hope you enjoyed that, and thank you very much for watching.